The way that IP networks know how to get to different IP version 4 or IP version 6 prefixes is known as routing, and the devices that do this are known as routers or layer 3 switches. These devices send packets crossing the network in the right direction based on routing information. This can either be done dynamically or statically. Static routing is when a network administrator configures the routing manually instead of relying on a dynamic routing protocol. So let's take a look at our diagram. We have two VMX routers, let's call them VMX R1 and VMX R2, and two loopback addresses that can represent hosts connected to each router. All configuration for static routes occurs at the edit routing options level and consists of a destination prefix and its associated next hop. Because static routes must have a valid next hop specified, which is usually the next hop IP address of a directly connected device. And obviously that IP address has to be reachable. However, on non-Ethernet point-to-point links, you can specify just an egress interface name rather than an IP address. It's also possible to configure a static route pointing to a null route. Now, you can use the keywords reject or discard, and the reject means that the device will send an ICMP network unreachable message back to the source, whereas discard won't send any message. It's just going to drop the packet silently. Like a ninja.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
We can also configure what is called a floating static route on other vendors' equipment by configuring a qualified next hop. In our diagram, our two routers now have an extra link connecting them. We will configure one link as the primary link with a static route to the loopback addresses, and if that link fails, then the backup link will take over and provide us connectivity. This static route has a higher preference than the current route installed in the routing table and can act as a backup link if the primary link fails and is removed from the routing table. Talking of preference, where a lower preference is preferred, we can apply a default preference to all static routes. But if they have an explicit preference applied, that will override the default one. Juniper devices require that the next hop IP address of static routes be directly connected. If you had a static route pointing to a device whose IP address is not directly connected, then the device isn't going to look it up. First, you need a path to the IP address of the device that isn't directly connected. This is probably best done through a dynamic routing protocol because it's going to also remove the static route if the indirect next hop becomes unavailable. Then you need to use the resolve keyword. What's actually going on here is that we are telling the device that it's alright to check the routing table to find out how to get to the next hop of the static route, even though it's not directly connected. And last but not least, in regards to static routes, we have the no re-advertise option that prevents the route from being redistributed via policy into a routing protocol like OSPF or BGP. So let's just take a look at our lab diagram. This is the lab diagram that we're going to actually be using. So we've got R1, R2, R3. Each of them have a loopback that represents their router number. So 1.1.1.1. R2 has 2.2.2.2, and .3, and R3 has 3.3.3.3. I have configured all of these interfaces. So let us look at the actual routers themselves. And they should each be able to ping their respective loopbacks and their connected IP addresses. So R1 can ping its loopback. It can ping its neighbor IP address on the top path and on the secondary path. So what I'm going to do first, I'm going to do a static route to enable R1 to be able to ping R2's loopback, because currently it cannot. And as we saw in the animation, all static routes are done under the edit routing options. And what I will do is set static. Now we're going to the loopback of R2, which is 2.2.2.2. And our next hop to get there is 192.168.0.2. And that is it for our initial option. Let's commit that. Let's try that ping again and see if it works. Which it now does. That's excellent. That's how we've configured a static route. We are also able to configure a null route. So if I done a static route for 2.2.2.2 and also I done a static route for .3, commit that. We should now be able to ping 2.2.2.3, which we can. But what I want to do is I want to make that a null route so that it just drops it. And now there's two ways to do it. We could have a no route to host or just nothing. So the default is the no route to host, which is the reject option. So for this static route here, let's see if there is a reject option. So we see discard. Oh, there is a reject option. Okay, so we could say reject or discard. We're going to say discard so that we don't get anything coming back. And you see the difference here, it's just blank. Whereas previously, when we couldn't get there, we were getting a no route to host. And that's the difference between a discard and a reject. When you do discard, you don't get any response whatsoever. Excellent. What we could also do for the 2.2.2.2 network, we could do a qualified next hop, which is what we call a floating static route with other vendors. If we do a run show route, we can see that we have a static route to 2.2.2.2, and we have what we want to do. We want to add another route in here with a higher preference. And what that means is if this static route disappears, the other route will take over. And the way to do that, if we up arrow a couple of times, so we're saying to get to 2.2.2.2, we're going to use the qualified next hop of 192.168.0.6. Now if we look in our diagram, we'll see that our primary route here goes to .2 and our secondary path will go to .6, and we know that the preference by default is 5. So if we make this preference, I don't know, 150 or something, then it will only take over if this primary route disappears. We could say preference at the end of 150. So we've got our primary route here is 192.168.0.2, and we've got our backup route, which is of 150. Let's commit that. Have a look at that in the routing table. And we can see that our primary static route has a preference of 5, and our qualified next hop has a preference of 150. So what we can do, we can try and simulate a link failure and see what happens in our route table. Deactivate static 2.2.2/32 with the next hop of 192.168.0.2. Let's commit that. Run show route for protocol static. And we can see now for the 2.2.2 network, we only have the qualified next hop in our routing table. So it will be using the qualified next hop to get to 2.2.2.2. And we can see that we still have reachability. We're going to do a rollback because we'll have our primary route back. If I say a rollback 1, we can see that we have both of our static routes in the table. What we could also do is we could change the default preference for all static routes. Edit static, and we say default. If we change the preference here, let's say change it to 180. And now let's say set to 180. This will change all of the static routes preferences, apart from if they've been specifically configured. So actually our qualified next hop should be the primary route now. And we can see that this first one is the primary route, so it's going to use our qualified next hop as the primary route, and the other static route will actually now be the backup route. The last thing that we're going to do is look at the resolve option. Now, what is the resolve option? What does it do? Let's go back to the diagram. And we're going to see here that with static routing, it's not going to do anything unless the next hop is directly connected. Now, if R1, let's say this one, wanted to get all the way over to the loopback of R3, the next hop we can use as 192.168.1.32, but this is not a directly connected route. So we advertise all of these routers into OSPF, and what the resolve option is basically going to do is, instead of looking for a directly connected next hop, you're going to search in your routing table. So if we were to do a static route at the moment, let's say edit static, set route 3.3.3.3/32 with our next hop of 192.168.1.32. If we were to commit this, then we won't have reachability. Run ping 3.3.3.3. We've got a no route to the host. And the reason is because 192.168.1.32 is not directly connected, even though we should have it in our routing table, because I've advertised all of these routers into OSPF. So we do run show route, and we see that we have the 192.168.1.0/24 network being advertised via OSPF in our routing table. So all that we have to do, if we run this last command and we say resolve on the end, this resolve keyword now says you can look inside your routing table and it doesn't have to be directly connected. If I do a commit now and run the same command, run ping 3.3.3.3, boom, we have connectivity. Alright, that's all for static routing. We're going to move on to the next lab.
It's question time. Question 1. In a Juniper Networks router, when configuring a static route with the discard action, what is the intended outcome of this configuration? A. The static route is marked as unreachable, and packets are dropped silently. B. The router sends ICMP destination unreachable messages for traffic matching the static route. C. The router drops all received packets without sending any notification. D. The static route is advertised to neighboring routers with a preference for discard. The answer is C. Question 2. In a Juniper Networks router, when configuring a static route, what is the purpose of the no re-advertise statement? A. It prevents the router from re-advertising the static route into any dynamic routing protocol. B. It disables the automatic re-advertisement of the static route into the local routing table. C. It instructs the router not to share the static route information with neighboring routers. D. It allows the router to re-advertise the static route, but only to specific neighbor routers. The answer is A. To get the complete question banks for all the JNCIS-ENT videos, drop us an email at info@routercoach.com.